Okay, good morning everyone, and welcome to our keynote address. My name is Ernie Bergstrom with Crystal Q Consulting, and it's my pleasure this morning to introduce to you Mr. Arpit Jachapura, who is Vice President, Product Management and Strategy at Dell. So let me just say a few words about Mr. Jachapura. Like I said, he is Vice President, Product Management and Strategy at Dell Networking. A strong advocate of network virtualization and software-defined networking. He has emphasized their use in developing switches that are cheaper, use less power, and occupy less space. He has helped lead Dell to rapid expansion in the switch market, so it is now third in market share for 10 gigabit E switches, and second only to Cisco in the 40 gigabit market. Is that right, Chuck? He heads the marketing effort that has positioned Dell as a leader in next-generation high-speed networking to meet the needs of the data explosion. Arpit joined Dell through the acquisition of Force 10 Networks, where he was Chief Marketing Officer. Before working at Force 10, he was Vice President, Strategy and Market Development at Ericsson, and Vice President, Product Management and Marketing at Redback Networks. A networking veteran with over 20 years experience, and he has held executive management positions at CINA, ONI, Caspian Networks, and Nortel Networks. He received his MBA and his Master's in Computer Engineering from North Carolina State University, and his Bachelor of Science in Electrical Engineering and Telecommunications from Gujarat University in India. So let's give a warm welcome to
That was half the keynote, sorry. So when, I'm sure you're asking, what's a networking guy doing in a server summit, right? My vision is to make networking behave like a server, okay? Okay, so that's what our goal is. It needs to be as simple as a server, and it needs to be, as tied in with the server applications that go on in the industry, right? So that's kind of the thinking that we have, and we are marching down that route, as you can see from the industry. Now, here's the interesting part. When Lance and I were discussing on, what should I cover, right? I mean, there's so many topics. And he made it, and there's Lance, right? So when we were discussing, he said, all the acronyms in the industry have been used in all keynotes, so don't use them anymore. Right? Don't talk about it, don't do anything. The only thing you can highlight to my audience, and we're talking about, our discussion, is, show them real examples of what can be achieved. Right? And that's hopefully what I want to talk about today, right, in the latter half of the keynote, okay? And so what I want to do is bring home the entire kind of ecosystem at the IT level, where really what you've heard over the last several days is kind of loosely coupled, three buckets. There's an application bucket, there's a software-defined software bucket, and then there's the hardware bucket all the way down to what we just heard at the chip level, okay? So those three, when they come together, they make future-ready IT, happen today. Okay? And so what I want to do is very, very quickly walk you through how this is possible. Okay? And this is possible because of very simple disruptions that happen in the industry. We all know this. I'm not going to spend too much time. Mainframes, quote, disappeared when x86 disaggregated. ASICs were made by a different company, then a software, then an application. Okay? That led from terminals to mobile computing. Well, guess what? The only industry that did not do this is networking. And so Dell started this journey, what's called open networking, where we announced the disaggregated model. On our switch, you can load anybody's software, in terms of a third party. And you can load applications on it to make it do what you want it to do and not rely on a proprietary vendor locked-in architecture. So that is basically where we have come from, and it's completely an open kind of an environment, right? Now, in that environment, when you abstract it at the IT level, we still have the legacy silos. Okay, you have the server silo, storage, networking, software silos. So let me ask, show of hands here, how many you manage or work on servers? The obvious one. A lot, right? How many networking folks here? Oh, quite a few. How many storage? Quite a few. How many software? Even? How many all? All of the above. You are converged. You're the ones that kind of will get this message very clearly, right? And so here's the difference, right? Each of these have their own data plane, control plane, management plane, orchestration layer, tools, organizational skill sets, people, etc. And we've been fine till now, right? What happens is customers just beat us up for price and performance, and we keep working that angle for the last 20 years. That's what we've been doing. Well, the world is changing. From a vertical model, we're moving to a horizontal model. And that model now has stitched server storage networking, abstracted it with a level of virtualization, and a simple OS that runs on it, with a set of middleware that gets you to the application and the workload. And it is what I nicely call moving from a hot dog model to a lasagna model, right? Right before lunch, sorry. But that's kind of what needs to happen in the industry. This puts organizational skills upside down. This puts your job upside down at risk. This puts a lot of pressure on today's IT environment. It is not ready for the future. And so what I want to do is show you a path on what are some of the ways you can get to a future-ready IT that is, as I said, application-centric, software-defined, and hardware-accelerated. Okay? So that's your checklist. Let me hit each one of them in a little bit more detail. So here's the enterprise horizontal stack that I just talked about. SDN, as you know, is a technology, software-defined networking, that has enabled this virtualization of network. And on the right-hand side is what you see, a typical diagram that an IT admin would be running, where you have a whole bunch of racks at the bottom, right? Whether it's servers, storage, compute, color-coded for your reference. Blue server, purple is storage, orange is network. They all come together in different types of racks, blade servers, rack servers, different types of scale-out designs, connected to a fabric, into a campus, moving into a data center, remote office, branch office. Very traditional setup for any small, medium, or large enterprise, right? And the goal of the IT manager is to support the business that runs productivity tools and new workloads. Big data, Hadoop, VDI, you name it. Now, one thing I'll highlight on new workloads that I call it, not a traditional, exchange and things like that, but the new workloads place a very different demand on the data center, okay? Specifically networking. These new workloads require traffic to go between servers. We call it east-to-west traffic, okay? And so it is really servers to servers. So I'll give you an example. When a VDI as a workload gets set up, a PC opens up, a message goes to one of the servers saying, the user has logged in. That's kind of a north-south message, or a user to a data center message. That message spins off multiple high bandwidth requirement message between servers. Fetches exchange environment, fetches link environment, fetches applications, etc. That's all east-to-west traffic, right? And we've learned that from our web customers, right, the Web 2.0 customers, the Facebooks and the Googles and the Microsofts of the world, memcache type loads, right? Very heavy on east-west, right? When you're doing these dynamic linked lists and things like that, very heavy east-west. So it puts a completely different pressure on the architecture where it needs to support workloads. And this is one significant difference on how you would build future-ready IT. Okay? If you take the same enterprise concepts of workloads and flip it around to carriers, the AT&Ts and the Verizons and the Telefonicas of the world, on the network side, they are experiencing the same shift. They call it NFV, Network Function Virtualization. Their goal is to focus on their applications, which they call services. And those are the acronyms on the top: VIMS, VPC, VCDN, VC. These are services that you and I, as consumers and businesses, use on our daily life. Mobile broadband, 4G, LTE, things like that. And in that same vein, they have to undergo the change of future-ready data centers, future-ready network, and future-ready services, right? And they are all kind of built on the same principles. So if you now look at the total ecosystem of sort of, who has the future, it's the enterprise side with the software-defined enterprise, and it's the carrier sides with the software-defined carrier. Between the two of them, right, you have the common DNA and the common framework. And this is extremely important to the people in this room who are working on servers, because it is a server-centric world. And you didn't hear it from me as a networking guy, okay? But I will concede that. It is a server-centric world. The only thing we should not get arrogant about from a server perspective is one server will not be enough, okay? And so we need a farm of servers, which means you need to drag in switches that connect it, which means you have storage sitting in the architecture, and now it is an enterprise data center that I just talked about. Okay, so they share the same DNA as I said. So very, very important. In fact, we have estimated in Dell, right, the market sizing, on the right-hand side, which is the software-defined carrier and the whole NFV transition, to be about the same as the enterprise spend in the next 10 years. Huge, huge potential and opportunity. Okay? So that was kind of the applications that enterprise go after. Then you click down and say, well, I need agility in today's environment. It needs to be software defined. Most popular buzzword. I thought I might as well throw it in just to sort of make, Lance mad a little bit. But that's okay. But this is the real stuff, right? It's not just a slide explaining what SDN is. That's 2 years old. SDN, software defined has 3 components to it. There's a networking component, there's a storage component, and then there's a cloud orchestration sort of application usage component. You can get to software-defined storage in many ways. You can get it by putting, high-end storage on an x86, and Dell has, announced several appliances with Xenta and Nutanix type innovators to support that model. You can go down the software-defined storage path using the traditional, what I call, hypervisor approaches, whether it's with OpenStack and Ceph, or VMware with vSAN, or Microsoft Spaces. Same thing on networking, software-defined networking. You can go down the software networking path either through, direct SDN technologies using standard-based controllers and things like that, or through hypervisor-based technologies that I talked about, VMware, Microsoft, and things like that, which I'll show you in a bit. And then cloud and orchestration, again, as stacks emerge, there's always going to be a proprietary stack, which will be slow to respond, and we nicely call it hardware-defined data centers as opposed to software-defined. But at the end of the day, that's what gets you. Okay? And so here's a little bit more detail on how the stacks line up. With VMware, OpenStack, and Microsoft, and you have the underlying infrastructure, and you have the hypervisors, you have the virtualization layer, and you have the cloud management on all 3. And the key here is those arrows that are shown that are open, standard-based, and sometimes even proprietary. Okay? They have to get to a point where it is completely automated, where a VMware server admin who is doing vCenter should not know what a switch is below him. Okay? We have done a very, very disaggregated model here where we have, we support third-party OS on our switch. So we have Cumulus networks running on our switch. And if you have Cumulus running, you will look at a switch just like a server. If you're using Puppets and Chef and things like that, just straight in, no CLI, okay? No Cisco certification required in the new world, okay? That's how we look at it, okay? And then the final, piece of the puzzle is hardware acceleration. We just heard, AMD talk about all the innovation in the chipsets, right? I think the next one's from Intel. So I'm kind of sandwiched between chipsets. It's good, but it has to happen. Innovation at the silicon and the hardware layer cannot stop because software-defined only can get you a limited amount of agility, and it is important, but the hardware acceleration is absolutely critical. And so to get to the point of imagine what you can do with these things, right? I've taken some examples of what we discuss with our customers, and just to show you, I'm trying not to make it a commercial, but guess what? It may come out that way. So the first thing is you need to boost the compute efficiency, okay? And the way you go about doing it is imagine that in a big data, whether it's Hadoop or anything, you get 5 times more compute per rack. And you have 0 premium for that density, meaning you're not paying more and you're not changing the environment, right? If you're doing web farming, 8 times more servers. And again, this is compared to the previous generation and competition, obviously. Less cables and 0 touch, just comes up. And the best I like is the whole scale out, the whole database scale out, right? You are a company that's processing orders. You take orders per minute, right? You just increase your orders 6 times, right? At 40% less cost in terms of orders per minute, right? Those numbers have been tested, proven by our customers. And this is the kind of hardware acceleration and innovation you're getting. When you actually, go through your application-centric and software-defined solutions, at the end of the day, it needs to run on a physical infrastructure. And those are the numbers, we have shown with some of our latest technologies that Dell announced. It's a PowerEdge FX2 converged system, 2U, servers, integrated storage, and integrated networking, right, on the backplane. And of course, completely open to run multiple stacks that I just talked about, okay? So you got to do that, and that's a given, okay? The next thing you can do is accelerate the storage performance, right? We're seeing both types of storage technologies emerge. Hot storage that needs to be extremely close to a compute, and then of course, tiered storage that goes across in the other parts of the region. So here's some innovation that we have announced publicly, which is 5 million ions, right? Now this is huge. This is huge. Now I'm not even sure if anybody's ready to deploy this level of performance from a storage perspective, but you can do it. And what it does is for database response time is like 99% better. Now all of these run on 40 gigabit Ethernet and very, very fast flash pool, and a lot of whether it's fiber channel or iSCSI, it doesn't matter. You're running TCP and you're running transparency and reliability. There's a lot of internal architectural details which I won't go into, but you can do that level of acceleration on the storage. Okay, and then on networking, what you have to do is you have to take the servers and turbocharge them, right? Servers today have only been used as control plane or management plane in networking. All data path went through traditional silicon vendors, whether it's proprietary vendors like Cisco or open silicon from like a Broadcom or an Intel, okay? This is the first time, and we are starting to see demonstrations like what we just announced of running, over 240 gig through a single server. Now, a single server is not just the right answer for replacing a switch, it's not a one-to-one. but it's a farm of things and a pool of resources. Okay, so think about it this way, right? Hardware acceleration is a fundamental building block. You turbocharge your networking, accelerate storage, and then boost your compute. That's your hardware defined. Hardware accelerated, then you get to the software defined, you get agility, right? You get simplicity, you're not touching anything, server storage networking, and then of course, you have to view at it from an application-centric perspective, okay? And we have to do all of this without locking the industry. And that's a Dell promise, right? It's all about embracing open everywhere from a standards perspective or a open source perspective. And both paths are fun. Open source gets you there a little bit faster, but then it takes iterations to be ready. And standards supplement it in areas that are not there. So all these things you see happening in the industry, open compute, open networking, EDC, OPNFV, all these, if you're not familiar with it, we can discuss it offline. But to get to the future-ready IT that I talked about, and to get to that performance and that boost that I'm talking about, you got to keep it open and get those three checklists: application-centric, software-defined, hardware accelerated. So that's kind of what I was prepared to talk about, given that we don't need to talk about other acronyms. What questions can I take? I think I have about 5 minutes. Yes?
My name is Georgia. Currently, we have two network systems. One is the wide internet, which is a TCP/IP-based packet switch system. Another one is a wireless techno system, 2G, 3G, 4G, 5G, which are circuit switch system instead of IP address. So the big challenge for IT application is how to integrate these two systems together, and what is your opinion?
Okay, so the question was, in a typical enterprise, you will have traditional voice systems and running regular, what we know, phone services, mobile or fixed, and you would have the data networking, TCP/IP-based kind of systems on the LAN side. How do you integrate it all? Well, I would say you start with the applications. Again, remember, applications, software-defined, hardware accelerated. The applications in this sense would be, collaboration suite, UCNC, as we call it, right? And this unifies it all. You can run that app on server farm, right? And then you collapse your WAN down into the data center, and you allow for more software integration from that perspective. So, we can take your specific case out, but at the highest level, the technologies are available today to collapse and eliminate. Now, you got to be careful. Is it a rip and replace or is it a migration? There are different approaches there as well. Yeah.
What is your take on OCP as a threat to commoditize the server business?
So we actually embrace, as I'm going to repeat, open again, and I'm going to highlight right there is OCP. Okay, so I don't believe it is a threat. We embrace OCP, and we believe, in fact, we set contributions to OCP. We work with them. What it does, just like OCP and ODL and OPNFV, right? All these open source projects, what they do is they create a path of what is achievable, okay? And what can be commercialized. Where Dell comes in and where some of our other colleagues come in, is there's still a need to execute the commercialization in terms of global support, global delivery, 4-hour turnarounds, taking it out of customs in Hong Kong. Right? It is like the logistics in 199 countries are not something that OCP will control. Okay, so we like the path of open, right? Because it's not closed, obviously. But the logistics and the commercialization is where we will excel. Okay, and of course, working with them, we can influence the direction as well.
So on the topic of open, so are you open to use ARM 64-bit?
You know, that is out of the scope of what I can answer. I know my limits. Okay. But I can connect you to the strategy folks who are looking at that problem. And there's some good ideas.
So you're open to connecting.
In fact, one of my colleagues has just joined. Yeah. So there you go. So things will happen. Collaboration will happen. Okay. Other questions? Yeah.
Do you agree the line between server and switches is kind of getting blurred?
Yes. So the question.
Impact on the system vendors and the switches.
Very good. So it's a very good question. Do you believe that the lines between servers and switches are getting blurred? And how will it impact the system and the switch vendors? So in fact, not only do I agree that it's getting blurred, I want it to get blurred. Okay? So our vision and strategy is based on a fundamental question that says, why should a network stop here or a switch stop here? Whether it's a NIC or a CNA or an adapter or whatever, why should a switch have a control plane and a data plane, right? Why should a server look like this, right? So we are actually we're spending a lot of R&D to redraw the lines between server storage and control. And the example I showed with FX is exactly that, where most of the switching is connected on a PCI on the back, on the mid plane. So the clients don't even see it. It's all embedded. It's just like gone. And then on the outside, it is completely standard based so that you can connect it to the traditional switching vendors, right? So that's the first part of the answer. The second part of the answer is, if the momentum continues on open, I believe it is a big threat to the traditional vendors, right? 20 years ago, we had the mainframe revolution to x86. Today, people who resist the migration of proprietary closed system to an open architecture will have the same issues. 5,